Hey, this is Dinesh here. Today I'm going to give a brief status update about my first MPW project, and also it is a first in my Riscduino series. Let me give a brief introduction about the design. So this design has a 32-bit RISC core and a quad SPA. The purpose of the quad SPA is to behave like an instruction memory for the RISC core. I had a 8-bit SRAM controller. This is behaves like a data memory for the RISC core, and I built in a multiplexed UART USB and I2C interface for external communication. Apart from this, design has a wishbone interconnect and a general purpose register. Whole thing is get connected to the Caravel through the wishbone host. So implementation wise, if you see it, the design is simply hardened with 7 big macros. Each are independent macros and they are independently time closed. And since there was no way you can adjust the latency within the open lane flow, I kept a clocks to adjust buffers around the each macro, and these buffer delays are controlled through a register in the wishbone host. From the design angle, I kept there are 4 different clock domains there, so each are colored differently. They are indicating they are in a different clock domains. We had a separate clock domain for SPA, and these are in one domain. And RISC-core has its own domain. The STRM controller has its own different clock domain, and Wishbone host has a different clock domain. So design complexity wise, it is a 100K complex design. If you see the total GPU pad requirement for this design, I need 30 pins for STRM controller and 6 pin for the quad SPA and 2 pin for the UART. So effectively, I need all the 32 pin GPU in the Caravel for my chip bring-up. As you know, there is the issue in bringing up all the pads in MPW-2. So I try to partition my bring-up into 2 phases. One is a basic boot and second one is a full boot. In full boot, I need all 38 pin, but in basic boot, I need only 8 pins, which includes a 6 bits for a quad SPA and 2 bit for the UART. So in this phase, the RISC-4 is trying to boot from the quad SPA, and I try to push the messages through the UART. So then I will start hunting for the MPW-2 chip. So what I noticed is the first chip, the working GPU low region is 0 to 18 and high region is 35 to 37, which was not useful for me. So the next chip when I tried, it was working range was 0 to 13 for the GPU low and high was 30 to 37. So this is what was good enough for me for my basic boot. So all my test cases bring ups are planned with the MPW-2. In this bring up phase, I use this Spartan 6 Xylence board apart from the Caravel hat. Just a brief introduction about this board is this is a Spartan 6 board. It is a 144 QFP packaged one, and it has a 100 megahertz oscillator and 70 user defined IOs are there, and it cost around $49. One of the main advantage with the FPGAs are its pads are user controlled, so you can decide what direction you want, and based on your design digital requirement, you can configure them in input or output. And it has inbuilt 100 megahertz clock, so that you can generate whatever clock you want. And also it has a 20K cells and 100 KB of RAM, so you can model whatever functionality you want, and you can directly interface all your digital signals to a FPGA. Apart from this, we may need one regulator. Here is the screenshot of the logic analyzer capture on the live system, and here I try to show the quad SPA transaction information with enable clock and fork data signals and UART transaction TXT information. You see the basic C code used in the RISC core is once it boots up, it configures the UART core for its baud rate, and checks for the before status. If it has a more than 12 location, then it repeatedly drives the hello world into this. Let us check the demo setup. Here is the MPW-2 die packaged one, and this is the microscopic view of the die, and this is the caravel hat, and these are the board I used. One is FPGA. I created an adapter to connect a caravel hat to the FPGA.